All right, in a previous lesson, we've been studying end behavior, turning points, leading coefficient, and degree. And now we're going to go ahead and move on to, we're going to be giving you a polynomial function graphed, and we want to find the important pieces. So here is our polynomial, and we want to find the zeros. So the zeros are going to be your x-intercepts. So let's go to the x-axis. So here's our x-axis. We wanted to find out where it touches on the x-axis. So it touches at this first point at 2, 0, and then at -1, 0, and then that last point there is -4, 0. So those are the x-intercepts. The zeros are x equals -4, -1, and +2. Next is to find the y-intercept. The y-intercept is where it crosses the y-axis. So here's our vertical axis. And we find out where it touches the y-axis, and that ordered pair is over 0, down 8. Then we want to find out where the graph increases. So think of increasing as, if you were to create a line, what would be the positive slope if we had a line, but these are going to be curves. So the first positive interval is right there. So when we do intervals, we do these on the x-axis. So that point that it's its lowest right here is over 1, down 10. So the interval for what that blue piece is increasing is again on the x-axis. So that would be at 1, and then it goes to infinity. It also increases in this piece. So that highest point, which we're going to call our local maximum, is the ordered pair -3, 10. So it stops increasing on the x-axis at -3. So we say it's increasing from -infinity to -3. I'm just going to write the and. Where is it decreasing at? It's decreasing in this red piece right here. So again, on the x-axis, it increases or decreases. So it's going to have a negative slope on the x-axis from -3 to +1. Then we'll do our local maximum. So up here is our local maximum, and that's a turning point, -3, 10. And then down here is our local minimum, our other turning point. And then our domain and range is -infinity to +infinity for both. And then does this graph have a positive or negative leading coefficient? So that brings us back to our end behavior. Notice that it's rising on the right and it's falling on the left. So in a previous lesson, we worked with end behavior. So this is going to be an odd degree because both of them go in opposite directions. We're rising on the right and we're falling on the left. And then the leading coefficient is going to be a positive because it's rising on the right and it's falling on the left. And then we already did our domain and range, so negative infinity to infinity for both. All right, here's a second example. We're giving you a new graph. Let's go ahead and identify the zeros. So here's our zeros and those green dots. So the zeros are at -3, -1, 1, and 3. As x-intercepts, they're written as -3, 0, -1, 0, 1, 0, and 3, 0. The y-intercept, where it crosses the y-axis, is right up here in the red, at the ordered pair 0, 2. Then we want to find out where the graph increases. So the graph is increasing in this blue region here and that blue region here. So I'm going to identify the local max and mins first. So this is a local min and a local min. So -2, -4, and 2, -3. And then this red dot right there is our local max. So those are our turning points. So we have 3 turning points. So this blue piece, we go on the x-axis. It increases from -2 to 0 on the x-axis. And then it increases from 2 to positive infinity. Decreasing, negative slope, think. It decreases here, it decreases there. So on the x-axis, it decreases from negative infinity to -2 on the x-axis, and from 0 to 2 on the x-axis. Then we want to identify the end behavior. So notice that both sides are going up. This one is rising, it's going up. The left side is rising or going up. So both ends are up. So we're going to have an even degree polynomial since both are going up. Then we're going to have a positive leading coefficient because both sides are going up. Our domain is negative infinity to infinity. And now our range, the lowest y number right here, is at y equals -4. So y greater than or equal to -4. Example 3, draw a rough sketch. So we're giving you a polynomial function in factored form. So first thing to look at is the leading coefficient. The leading coefficient is a positive number, or a is greater than 0. And you have 4 roots, 4 factors. So what that's telling you is your degree is going to be 4. So that's an even degree. So the end behavior is both ends will be up. So it's going to rise on the left, and it's going to rise on the right. Then what we do is we find the roots. So we're going to use our zero product property. We're going to set the function equal to 0. And then find the roots. So we would set x plus 2 equal to 0, and we'd solve it. We'd subtract 2 from both sides. So our first root, or x-intercept, is going to be at -2. Then x plus 3 equals 0. Solve it, and we get -3. X minus 2 equals 0, so x equals 2. X minus 6 equals 0, so x equals 6. So what those do is they produce our 4 x-intercepts. Then what we do is we do our end behavior. So our end behavior is on the farthest side. So we know that we have to rise on the right. So we go to the farthest x-intercept and rise it, the farthest x-intercept and rise. Now our degree is 4, so we have n minus 1 turning points. So 4 minus 1 is 3. So we have 3 turning points. So that means we have to have 1 turn there. And we could go like this, make another turn, and then 1 more turn. Now how far they go up or down, we're not sure. That pink area, how far, we're not sure. So there's going to be a local maximum and minimums on those blue dots. And that's just a rough sketch.